But let's quickly, tell the viewers also in layman knowledge, and for that I am there. We've got, space educators and scientists on the panel. But to tell you guys about what's really happening, I have learned that information in a simplified format, so I'll put it out there for you. Now, payloads on the Pragyan rover. There are essentially two payloads, and Group Captain and Sujay, please do come in, and if you think I've uttered something wrong here, do come in. Now, it has two payloads. The first one is the APXS. It's called the particle X-ray spectrometer. It will derive chemical composition and infer mineralogical composition and will enhance enhance our understanding of the lunar surface. Like Group Captain was telling us, it's going to look beyond what the eye can see. Then you have the LIBS, which is also called the laser-induced breakdown spectroscope, will determine the elemental composition of the lunar soil. So, magnesium, iron, all these elements that we already know of, there could be a possible addition to what we know already of back here on Earth. So, it's going to take a look at the soil and rocks around it, essentially, right? And just to tell you that, the Pragyan rover has, in terms of its specifications, the mission life is 1 lunar day. What Group Captain Jha was also telling us, that essentially just 12 days on Earth. 12 Earth days is our potential mission life. The mass is about 26 kilograms. Takes about 50 watts of power to use. It has two payloads, LIBS and APXS, that we spoke about, and the dimensions, it's quite small. We have pictures running all around us, but the communication aspect, it can communicate with the lander. Group Captain, I'm going to come to you. Just want to probe, even as the Pragyan rover is going to probe the lunar soil, I want to probe what's going on with Sujay. Sujay, APXS and LIBS, would you like to elaborate a little further on what Group Captain Jha, where he left us?
Okay, so to make it very simplified, so a spectrometer or a spectroscope is a device which can detect what components or what kind of composition a material has. So imagine it like this: you must have seen the crackers in the Diwali days or any other
Right,
celebration.
right.
You would have seen crackers. We would have not paid that much attention, but you would see different colors of light which will come out of the crackers. Now, the reason why those specific colors come out is because of the composition of the materials. So each of the atoms which we have its own characteristics on color. So a spectroscope will detect those colors, and based on that, you can determine what is the composition of certain materials. So that is what, in term, both the subsystems or both the payloads are trying to do. One is looking at the surface, one is looking beyond the surface, in a very simplified terms.
All right. Thanks for the simplistic,
I,
absolutely. Group Captain, do come in. What the additions that you wanted to make, and whilst you're making those additions, do also tell us that with whatever experimentation the Pragyan rover will now carry out, how does that pave the way further, the road ahead for future experimentation on the South Pole as well? But do continue with what you wanted to add on, echoing to what Sujay was talking about.
two things. What you mentioned, the potential life of 1 lunar day. There, I just wanted to correct you. Potential is there for many lunar day, but it is planned. The proposed life of 1 day, that is ISRO planned. But all of us, we are convinced that when the sunset happens, at the time of sunset, all the systems will go to sleep mode, like our laptop or
Right,
something.
right.
When the power is, it goes to the sleep mode, and when the next sunrise happens, when the sunlight again starts falling onto the solar panels, then again the energization of the entire system will happen, and another day of experiment of those 14 days, 14 Earth day or 1 lunar day is possible. Such many cycles are possible. It has the potential to carry out that. But right now, ISRO has planned, proposed that, okay, 1 lunar day is going to carry out all these types of experiments that is already in the plans. But
That's going
what
to be
I
a
mentioned
great
to you,
bonus. That's going to be a great bonus.
what I mentioned to you, that in the spectroscope, laser spectroscope, what sends the signal impulse, laser impulse deep into the surface, many meters can go there. in case if ISRO wants to look for those unknown elements. Right now, it has fed algorithm for the known element. The known element in the equator region are there's the oxygen molecules, they are the silicon, they are magnesium, iron, calcium, aluminum, chromium, titanium. These are already known in the equator region. Uh, and mind you, those must be contaminated with the impacts of those meteorites, asteroids, comet, celestial body, which has come from outside the lunar mass. So those could be contaminated. But what is the actual of the original lunar mass is the one which will be here right now. ISRO must have fed that algorithm that should it be magnesium, this is the type of configuration that the laser spectroscope is going to find it there. But suppose they open the loop of those algorithms, then there will be additional data which is unknown, which is beyond those known objects. Those data will start coming up there in the coming period, which right now we also don't know how an unknown uh, maybe molecule, unknown element will look out. So that is one area the open algorithm will tell us.
Wow.
As far as alpha particle is concerned, it is something like a salt test. All of us science students, we have carried out the salt test in our labs.
Right.
So we take the salt, put it under the flame onto the platinum filament, and then see the color of it, and then we analyze what is that salt. It is something similar, not exactly the same, something similar. That alpha particle is going to bombard those soil, those regolith, and then there is a further type of arena or the halo going to be created around that soil, which this spectrometer that will analyze that this is so and so composition, whether it is calcium sulfate, calcium carbonate, calcium chromate, or whatever it is there. So that is it going to tell. So these are the two which are going to tell you about the composition of in and
All
around
right.
the rover that it is there.
And the rover's distance is essentially just 500 meters around the lander, right?
That's, that's quite a lot. It is about 500 meters. It is corded also. This is one good thing that ISRO has done. They might not have been sure that what all are in and around the lander. Suppose if the rover goes somewhere and it falls into the shadowed area, then
Right.
what happens? Then the solar panel will not have the
Work.
energy type of
Right.
energy. So it has given a cord line,
An
which is
umbilical
lunar
cord,
tether
yes.
line, umbilical cord, for two reasons. One, that electricity supply, which is in plenty in the lander, and very less, about 50 watt of the power generation in the rover, and that may fall with the slant sunlight which is falling onto it because of being in the polar region. So energy generation may be less, electricity generation may be less. So in that case, power goes from the lander, and the data supply from the lander, from the rover to the lander is ensured by that tether line. So this is very good thing that they have done. That even
Absolutely,
if
absolutely,
the
Group Captain.
light,
This visual that we're also seeing, you were pointing out that there are various dark areas, but the topography in general, it's not easy for any rover to probe this particular ground. And talking about probing via various ground probing modules, China very recently it collected the rock samples as well.